too.
We do have a few things going on.
It's all good.
Right.
We got company
Cool.
from Kansas City, and so
Cool.
all the locals are here.
Cool.
Sweet. So today's reading was kind of longer, but was there any questions? I mean, the best way to answer the questions are with examples, and so hopefully the quiz will help with that. But was there any just questions in general?
I did on a couple of them, but we'll get to it. So I don't want to like go all the way down to a question and stuff because I already started.
Okay.
Yeah, me too.
All right. Sounds good. Did you have any questions, Lester, or just while we go along through the quiz?
Yeah, I mean, I didn't look at the quiz ahead of time. I went through the reading.
Gotcha.
So I won't say I've mastered it, but it kind of makes sense.
Yeah.
Okay.
All right. Sounds good. I guess we'll just go ahead and get started. So that first question, when calculating, while you are required to work on this quiz, where is it? Okay. Which hypothesis involves equality?
That's the null.
Hopefully it was pretty straightforward. The next question, remember that the p-value is the probability of obtaining a sample statistic, at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do we assume is true?
The
The
null.
null. Yep, that's what I got.
Yeah. Yeah, kind of unless stated or given, you always assume the null hypothesis is true unless proven wrong.
Yep. The fail to reject. Yeah, but.
Yeah.
Mhm.
Okay,
Cool.
question 5. Oh, someone want to read that one?
Yeah, I can. Which of the following represents the alternative hypothesis for a two-tailed test? I got the third one, HA mu not equal to 10.
Yep, that's what I got.
Yes.
Yeah.
Six. Which of the following represents the alternative hypothesis for a left-tailed test? I got the first one.
That's what I got as well.
How are you?
Then the next one is the right-tailed test. I got the second one.
I did as well.
Yes. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or alpha. Use this in the next two questions. Which relationship would result in failing to reject the null hypothesis? I don't know that.
Okay. I got the first one because the p-value can't be greater than alpha. So if you want to reject the null hypothesis, or the results saying failing to reject the null, it's the first one because I always think of eating the p-value. So it's that one. I don't know why I think of that, but
Alpha is what again?
That's the breaking point between rejecting and keeping.
The level of significance.
Yeah, yeah. Sorry about that.
All right, so for the next one, if we want, which relationship would result in rejecting the null hypothesis? That's when the p-value is less than alpha. So the second one.
what I got. Okay. The insurance company is reviewing its currency policy rates. When they originally setting the rates, they believe the average claim was about 1,500. They are concerned that the true mean is actually higher than this. Use the information for the next two questions. Which of the following would be appropriate alternative hypothesis? I put the third one. The average claim is greater than 1,500.
Yeah, it's pretty.
It's pretty self-explanatory in the information. It's kind of telling you it already.
Yeah.
They're concerned that the true mean is actually higher, so I'm like the average claim is higher or greater than 1,500.
Makes sense.
So then I'll do the second one as well. So which of the following would be an appropriate null hypothesis? So the null has to be at least equal to it, it has to be equal. So I put the average claim is equal to 1,500. So the first one. Because the null has to be equal to 1,500. So I'm like, okay, well, first one.
Okay, the insurance company randomly selects n equals 40 claims and calculates a sample mean of X bar equals 1650. Use the information to answer the next three questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
What do you think it is?
Yes, it is, because it's large.
Correct.
Yeah.
Bigger than 30, so.
All right, so the law, what theorem or law justifies your answer from the previous question? And I get them mixed up between the law of large numbers and central limit theorem, but I chose the central limit theorem.
That's what I did too. That's what I did as well.
Which of the following is the test statistic as defined in this lesson? That's the X bar. No.
Try again. Don't think of previous lessons. Just think of this one.
Okay.
Like kind of.
They're only giving us. Okay, so then it would be the 40 claims. The N. They only gave us two numbers for this.
So we're trying to find the test statistics. So it's actually Z. Because this has nothing to do with Z-score or anything, because S is different, N is N's totally different as well. And X bar, it was already given to us, and N. So N and X are out of the question. And then S is not the sample size. What is S? Shoot.
So even though we haven't found it, that's still going to be.
It's the test statistic. Or I think they're.
Is this lesson's definition different than previously?
I believe so, because the Z-score is not a test statistic, though, is it? I don't know, because I didn't see anything in the reading that said Z-score is a test statistic, but it's not looking for Z-score; it's just looking for Z.
Okay.
But crunch.
So it just says, since we know the standard deviation, we can use the Z-score to determine X bar. We call this the test statistic.
Okay, so they are looking for the Z-score then. Okay.
Yeah. So
it is
the Z is the
okay.
is the test statistic, X bar is the sample mean, mu is the population mean, and standard deviation, and n is sample size. There's nothing about S in this lesson, so.
Okay, cool.
Okay.
Okay.
All right, yeah, I can do this one if you want.
Okay.
The historical mean of the sale receipts at the grocery store is 150. The standard deviation is 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypothesis of 150. The null and alternative is mu less than 150. She will use a significance of alpha as 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X bar equals to 144. What is the Z-score associated with this test?
So it's still that same equation that we used before. So the X bar minus mu over standard deviation divided by the square root of n number samples.
Okay.
So we'll get 144 minus 150 divided by 40 over the root 36.
Okay.
Is how I went about it to find Z-score.
And then did you get negative 0.9 for your answer?
Yes.
Okay, then I did do it right. All right, perfect. Good.
And then the next question says, what is the p-value associated with the Z-score? And since our Z-score was the negative 0.9, we're going to shade the left side of our test statistic. So I got 0.184 when shading the left side using the normal probability applet.
That's what I got as well.
0.184?
Yeah.
Okay.
What inference would you make about the null hypothesis for this problem? So your probability is very low. So you're
Yep. That means that we failed to reject because we have insufficient evidence. Mm-hmm.
So as long as that p-value is greater than alpha, usually it means we'll always have insufficient evidence, and you should always fail to reject the null hypothesis.
Mm-hmm.
And
18, what is your conclusion for this problem? We have insufficient evidence that the true population is less than 150.
Yeah.
So the fourth one? Or
Third
sorry,
one.
third
Yeah.
one.
Third
Yeah.
one.
That's what I got as well.
there are two types of errors that can be made when performing hypothesis tests. Which one involves rejecting the null hypothesis when the null is true? And that's the type 1.
That's what I got as well. Cool. A researcher decided that instead of using level of significance alpha 0.05, he will use alpha 0.01. Which of the following will be true? It's the probability of type 2 error will increase because they're going to have it to be the null hypothesis to be false because it's going to be bigger. That was my thinking behind it. Probably the null will increase, not decrease.
It's kind of a sliding
So yeah,
scale. You go too big, the other one is got a greater probability of being wrong, right?
Yep. Yep. That's what I got.
Okay. If alpha equals 0.05, compute the probability of committing a type 1 error.
It's the same thing. It's 0.05. Because the type 1 error, we're trying to find out if it's going to be equal to alpha, and it is equal to alpha, the type 1, so it's 0.05. That was my reasoning behind it.
In establishing that alpha number,
Mhm.
they're giving them to us, but are we going to be required to calculate that for problems, or is that just a normal?
Most of the time they're going to give it to us, but in later lessons we'll have to compute it.
Okay.
Yeah, I think it's like two. I think next 2 lessons. I think.
Okay.
But most of the time, even if we get all of this too, they're going to provide it for us.
Okay.
Most of the time. Cool.
All right.
Let's send it in.
John, how is your throat doing?
It's doing a lot better. Thanks for asking. I've been drinking just straight honey to coat my throat, so I'm not scratching it up as much anymore.
I got a 25-round drum for my shotgun.
Wow.
Yeah, I'm gonna have some fun target practicing this weekend.
Sounds like fun.
Yeah, I'm getting ready for. So we're actually gonna go think about competing in a couple next season. So it'll be fun. I got it as an early Christmas present. So
Cool.
so the next time I can show you my hydro dips that I've been doing, and that's how I kind of have a side business on. So, but if you guys want to know.
Cool.
What is that?
So it's a hydro dipping. It's like a hydrographics through water, actually. So you put a tote down. I usually use a trough. It's a heated trough, and you put this film on top, and you can dip anything into like whatever kind of design you want. So I've got like digital camo. I've got skull and bones. I can do any kind of like sports. You can put Seahawks. You can do rims. You can do guns. You can do anything. I'm doing frisbee golf for a couple of my friends. Like they want to get theirs dipped. So I was like, I've never done it, so I might as well. So I just do different things and stuff. So kind of do it on the side.
Interesting.
Yeah. I'll show some probably next time Tuesday, because I'll have all my stuff back, because right now it's in the baker right now, so it's baking. Yep. Cool, guys. Well, guys, see you on Tuesday.
Yes.
Yep.
Perfect.
Thanks
Good.
for your help.
Yeah.
All right, see you later, guys.